Hello there and welcome back to another video. In this video, I'm going to be building yet another computer input control device. Yeah, I know, I've done a lot of these lately, but I promise this one's a little bit different and hopefully quite interesting. If you're familiar with my channel, you've likely seen that some of my more popular builds have been my rack-mountable macro key box, as well as my two versions of a per-app volume mixer that has motorized faders. I think all of these projects are super cool, and I'm so glad that many of you have thought the same. However, as great as they are, there's a very major issue with all of them, and that is that all of them are expensive to build. For some of them, literally hundreds of dollars in materials, and that's a lot. Plus, a lot of the features built into these devices are probably overkill for most people, so it's hard to even justify that really expensive cost with how overkill the device is. So what if I made a version of these projects that tackles a few things at once? The price being one of the main issues. I think that would be cool. So today I'm going to be building a device that gives you per app volume control on your computer with 4 physical non-motorized faders, as well as 16 programmable macro keys in a compact, inexpensive form factor that's pretty no frills, but that works darn well and that won't cost more than 60 something bucks to build. Now, there's nothing to write home about in regard to the design process for this device, as I basically just slapped 16 mechanical keyboard switches, 4 60mm slide potentiometers, and an Arduino micro onto a PCB and called it a day. And yeah, this makes for a pretty bare bones assembly, but honestly, that's what it needs to be to achieve the goal that I'm going for. There are a couple of auxiliary components on the board as well to help with the keyboard matrix wiring and potentiometer noise reduction, but honestly, there's really nothing too special here. And for the case, I designed it to be a simple 3D printed 2-part chassis, and the fader knobs and keycaps can both be 3D printed as well. I didn't want to build in any machined parts into this because the machined parts drove the cost up of the other versions quite a bit. And so, how about we just go ahead and get right into building this thing? I think that sounds like a plan. And the first part that we'll need to work on to assemble this device is the custom PCB that I got from today's video sponsor, PCBWay. PCBWay is a company that offers high quality custom manufacturing services. They have a very wide portfolio of capabilities, though some of their main ones are custom CNC machining, custom 3D printing, and of course, PCB manufacturing. All of their services offer a wide range of customization options regarding things such as material, surface finish, and more. Their products have made my projects feel so much more polished and professional, and at times, possible at all, because sometimes there are things that I just can't pull off on a prototyping board. If you're interested in building things and think that PCBWay's services could add to your next project, I strongly recommend that you check them out at my referral link in the video description. And thank you again to PCBWay for sponsoring this video. All right, the first step in soldering this build together is going to be modifying the Arduino a little bit. Now, I based this build around the Arduino Micro, and you might be wondering why I didn't go with a Pro Micro instead. I really did consider this when designing the project. However, I remembered my past experience with several different brands and models of Pro Micro boards, and it could be my luck, but Pro Micro boards have died on me, just randomly stopped taking code, and recognizing on the computer at all, far more than any other microcontroller I've ever used before. I have no clue why, but that's just been my luck. However, the Arduino brand boards that are based on the exact same microcontroller chip, the ATmega32U4, like the Leonardo and the Micro, have never given me a single issue. So while it is a little more expensive of a board than it could be, I chose to go with an official Arduino Micro for the sake of reliability based on my past experience. Now, strangely, the Micro with headers is usually cheaper than the Micro without headers. Not sure why, but that seems to just be the case. And so I bought that one. However, this board comes with the 6-pin ICSP header soldered to the top, and this sticking out will collide with the case in this design. So step 1 is to desolder this header. After that, I moved on to soldering the slide potentiometers to the PCB alongside their little bypass capacitors that help their values not bounce around in the presence of electromagnetic interference. These capacitors, once soldered, will need to be folded down or they'll interfere with the top lid because they're a little bit too tall. With that done, I soldered the 16 keyboard switches to the board, and I chose to go with Gatoron black switches because I like the feel of them and they're pretty cheap. If you don't care how your macro pad buttons feel, go ahead and use whatever keyboard switches you can find the cheapest, but honestly, I'd recommend spending like $3 more and choose a switch type you actually like the feel of for this, as it really does improve the overall experience. Now, I arguably should have done this before soldering the keyboard switches on, but I forgot to, and this is soldering the 16 1N4148 diodes to the matrix assembly. These are important to the design because without them, the matrix assembly may think that a button is pressed when it actually isn't, in a situation where the user is pressing 2 or more buttons at once. Next, I flipped the board over and placed the Arduino on the back of the PCB. I made sure that the USB port was facing the right way. In this case, that means ensuring that the USB port faces the back of the enclosure when the board is oriented in the position it will be in the final enclosure. If you're looking for a simpler rule of thumb, orient the board so that you're looking at the bottom where the majority of the solder joints and the Arduino are, rotate it so that the button matrix is on the right, and ensure the USB port is facing towards you. Go ahead and solder the Arduino to the other side of the board, and this will be quite cramped if you've already soldered everything else to the board like I have, so feel free to play around with the order that you solder things on in to make your life easier. Also, another note, if you're like me and like to socket your Arduinos with female headers so that you can easily unplug them from the PCB, you can't do that this time or the board won't fit in the enclosure. So just make sure that you don't end up doing that or you might have a lot of painful desoldering to do. And also, once the Arduino is actually soldered to the board, you don't have to clip the excess pin length on the side where you made all the solder joints, so feel free to keep that in mind if it makes your job easier, as I totally understand it might be hard to get flush cutters in there. And hey, look at that. The board is done. Well, almost, as there's one more modification to make. These slide potentiometers that I picked out, while nice Borns branded ones, have an issue, and that is that their stem is too tall. So you need to use some strong side cutters, don't use your nice flush cutters for this, to trim them. In particular, the length between the top of the notch in the stem and the new end of the stem should be 5 millimeters. One last thing, while you could use a rotary tool or hacksaw to do this job, it both won't be good for the potentiometer to have those forces and that level of vibration on its wiper assembly, and you could also get metal dust stuck inside the potentiometer, which will ruin it. So I really recommend just using some big side cutters like I did. All right, let's move on to putting the board in the case. The only thing to do before installing the PCB is to take a male micro USB to female USB-C cable and push it through the back of the case to give us a nice USB-C port on the back. I then recommend hot gluing that end of the cable to the 3D print so that it doesn't pull out when you're unplugging the USB-C cable from the jack. Then you just have to wrap the cable up inside a bit and plug the other end into the micro USB port on the Arduino. And now with the use of 11 M3x4 screws, we can attach the PCB to the case. Now, I know it seems like 11 screws might be overkill, and it could be, but for a control surface like this, the only support for the buttons and the faders is the PCB itself, and so not securing the PCB well could cause it to flex a bunch, making the controls feel flimsy and possibly weakening and breaking solder joints over time. So I really do recommend just putting all 11 in. Then the lid can be dropped on over top of the whole assembly and tightened down with 4 M3x8 screws. Then you can press on the fader caps and the keycaps. I 3D printed the fader caps, and I recommend that you do too, as this is likely the easiest way to get something you can be confident will fit and work. And as for the keycaps, you can absolutely 3D print these as well using one of the many Cherry MX keycap models online. However, I chose to go a different route for about $11, and that was purchasing a small set of blank, white, injection molded keycaps. I did this because I knew these caps would feel a lot better than something 3D printed, and I was more than happy to spend a little extra on this. And actually, that sub $60 price that I quote includes these keycaps. So if you want to skip this part, you can build this device for less than $50. And with that, the build process is done. Now it's time to get to programming the thing. Oh boy, I'm really not going to cover that much on the coding process because I'm not good at coding and I really don't like doing it, but I will quickly stop and talk about the relevant details of the program. That's mainly how the macro buttons and faders work in relation to actually practically using them with a computer. The faders, unlike with my motorized fader projects, work with Deej instead of MIDI mixer. This is because I've received some valid criticism surrounding the use of MIDI mixer for those other projects, because it seems that MIDI mixer as a software has been abandoned by its dev. Deej is another project that works to give you per app volume control with DIY physical faders, and it's a project that is much more actively worked on. So I went with that for the faders, and for the macro keys, I chose to go a pretty bare bones route because I wasn't sure of a better alternative. In this case, you will have to program your macro keys in the Arduino IDE. However, I've made it really easy to do this. I've included a demo macro that you can look through, as well as some commented, written instructions that should give you all that you'll really need to grasp the basic keyboard library commands that you'll use. And on that note, how about we head over to Live Audio Me to give this thing a really quick demo. All right, this is going to be the really fast demo of this little device. I'm kind of doing this in the exact same style as I would the demos for the motor fader versions of this. But again, this is going to be way shorter and sweeter because there's way fewer features to go through. The most important parts of this are that we've got 4 faders, and I have 16 macro buttons, and these can be programmed just in the Arduino IDE. I don't really have many functions programmed right now. I have macro 16 right here, which is set up with the demo macro. That's what the code will come with when you download it. There will be a macro on macro 16, and you can just press that and see what it does, and then you can look at the code and kind of figure out how it did that, so that hopefully then you can go and program your own macros. And then I only programmed some macros on these top 3 keys. They're super simple macros. They're honestly hardly even macro keys. It's more custom keyboard at this point, but still pretty cool. I haven't programmed anything for the rest of them. I'm sure I will at some point, but these 3 I programmed as media keys. So pause, play, rewind, and fast forward. So first thing that I'm going to do is I'm going to pull up Notepad here, and I'm going to press the demo macro. This should, right in the dock, wait a second, save the dock to the default path with a file name, and then it will open up a new dock and write some other stuff. It's basically just a demo of all the different functions and kind of how you can program them. So let's see it do its thing. So it's written in here, and then it waits about 6 seconds so you can read it. It saves it to the default file path, and now it's on another dock, and if we go to that file path, we should see, there we go, that's what it had done. So that's pretty awesome. I think that's a cool little demo macro. It shows you that you can actually do quite a lot on this. You're not just limited to typing stuff. You can also, save files and make new documents. You could program these to be Excel functions. And so that's awesome. This part of this system runs completely separately from the Deej part, and so let's move on to that. Now, I'm not going to give a tutorial on how to set up Deej right now. I will have that in the Instructable for this project, which will be linked in the description. All right, so you use the config.yaml file to basically set up what's mapped where. This looks like it's really complicated and clunky, and I thought it was as well when I was first looking into doing this. It's really not that bad. I promise you, it is not that bad. But you can see I have, so on this fader, I have my Apple Music. On here, I have a browser. On here, I forgot that there was a bunch of noise happening there. I have Minecraft for Windows. And then on this 4th one, I have Discord, which I'm not going to demo right now because I don't have Discord open. But that's how you configure these. And so what you can do with that is something along the lines of this. So I'm going to play this YouTube video, and you'll notice we don't hear anything. And I'm using a video that's not mine just so it's easy to differentiate the voices. And if I bring that fader up.
Other thing that I noticed is the fact that it doesn't have any off positions.
And you can mix that. You can mix your game in. So I'll hop into Minecraft here. So I'm sitting at a really loud gold farm. I can turn that way down.
Combination of both of these things
and put that video at a nice level.
Preamp with only one.
It really works the same way as the faders on the motor fader ones worked. Obviously, just these faders are not motorized, so you have to move everything manually. And I've also got some music going. So over here, I have just one of my regular playlists going. So I really got to be careful with how much of each song I end up playing. Otherwise, I will get copyright claimed. But you can see, you can do that, and I'm going to go ahead and I'm going to bring this up real quietly, and I'm going to press pause, play, skip, fast forward, so I can pause it, and I can skip, I can rewind, I can do all kinds of stuff. So, yeah, pretty awesome little box. All right, that's pretty cool, eh? At least I think it is. And in fact, I thought it was so cool and such a fun project that I actually chose to build a second one. However, on this second one, I made a few special choices. Namely, I stuffed the chassis with old packing foam as I assembled it, with the hope of getting the keys to sound even nicer than they already did. However, I have to say, this made little to no difference in the end. But that's not too big of a deal because I think the keys already sound good. But what I changed that did make a major difference was that I bought 2 sets of keycaps. One set of plain black ones and another set of assorted color ones. This meant that I could set the whole pad up with basic black caps, but as I programmed different macros in, I could color code the macros based on their function, resulting in a much easier experience remembering what's where, as well as a really cool, colorful looking keypad. I did stick with basic white fader caps in this case, but I have a lot of different color filaments laying around and could absolutely color code the faders the exact same way by printing a red fader cap for Apple Music, purple one for Discord, etc. Finally, I did change one more thing, and that is that I used the ironing option on my 3D printer to make the top surface of the lid a much nicer surface finish than the original one. That was totally worth the extra print time. I think that this project came out super well, and it totally nails its initial goal. It's relatively cheap to build, at least way cheaper than the previous versions of similar projects that I've done. It gives you physical fader control and macro keys, both of which are probably sufficient enough for most people, as let's be honest, a lot of people don't necessarily need motorized faders, or they don't need 32 macro keys, or they don't need a rack mount form factor. So I think the level of controls that I put on this one is much more reasonable. And finally, it's also a much simpler build than all of the other builds that I've done before. You basically just solder the components to the PCB, throw the PCB in the case, slap the fader caps and keycaps on, and that's it. That's the whole build. There's no crazy wiring, tons and tons of soldering, point-to-point connections inside the box, etc. And so I'm very happy with how this project came out. And if you're interested in building one for yourself, check out the Instructable link in the video description for a full materials list, as well as a complete, detailed written instruction set on every part of the process, and all of the resource downloads you'll need to build it, like the schematic and the code. Well, that's all that I have for you in this video. I hope that you were able to at least enjoy it, and maybe even learn a thing or two. In any case, I hope to see you next time. Goodbye.